Hello guys, we are live now with another session with another video. So you might wondering what's the today's topic. So from the title if you can't understand. So today's topic is poison distribution. What's the poison? Poison means zahar. Today we are going to see about zahar distribution. Okay, so before that let me give you one small question. Okay, so what is the question? The question is, let's say, what is the question? The question is, let's say we have 10 ball pens, out of which 6 are damaged and 4 are not damaged. Now you have to select 3 pens such that P of x equal to means exactly one pen is damaged. Now how you will gonna solve this question? You don't know. Why don't you know? Why you don't know anything? So tomorrow, not tomorrow, the previous lecture is binomial distribution. So let's check for the binomial distribution whether it satisfies the properties of the binomial distribution so that we can directly solve it. Okay, so first we have 10 pens, so we can say n is 10. We have to select exactly one pen, so we know that this is DRV means x is distributive random variable, okay, in which damaged pen. Okay, now let's see here what's the 3 possible condition. First, the events have only 2 possibility, yeah, 2 possibility, damaged or not damaged. First is satisfied. The second is the x is distributive random variable, so here our x value is 1, so which is distributive random variable. And third is the events are independent. Now let's see here whether the events are independent or not. So from this question we got to know that if we are selecting one damaged pen from 10 pens, now we have 9 pens and from which we have to select not damaged pen. So what we can see here, if we are selecting one damaged pen, then our total count will decrease by 1. So this is the probability of success. Yeah, we know that this is distinct, but the probability of failure here q, here this is also the q, so we got two different q's. So that's why here we can't use binomial distribution because this is a dependent case. So for dependent case we can't use binomial distribution. So what we can use, so let's solve this question now. So this is the constraint. So first let me write here, we can't use binomial. And what's the reason? The reason is dependent. Okay, now let's solve it. So as we know that, as we know that here replacement is not allowed, so let me write without replacement. Okay, without replacement. So we have to select one damaged and two not damaged, non-damaged. So we have three cases possible: D, ND, ND, 1 plus ND, D, ND plus ND, ND, ND. Now this is equal to 3 into 6, 10. As I told you earlier, non-damaged 4, but we have 9, 10, 3 non-damaged 8. We have to find the probability. Yeah, this is the probability. If you try to solve, you will get answer as 3 by 10. You can do it by your own. I will not do it that calculation. That's calculation very easy. Equal to 4 2s are 8, 2 3s are 6, 3 3s are 9, and here 3 3 cancel, so you get 3 by 10. Okay, so this is without replacement. That's our question is asking. Now we have another method. What's this method? That method is used when binomial distribution not, and it fail with one case, like we know that here p plus q is equal to 1 is not satisfying because we got a independent, we are not getting independent case, but x is drv, yeah, x is drv, and what's the other condition for a binomial distribution? The first is it should be a discrete random variable, it is impedant, and we have here two case means two story, which two story damaged and not damaged. Okay, so now what is the other method that can be used to solve the same kind of question? So this method is known as high geometric distribution. Okay, so this method is known as not okay, let me correct here, I was wrong, it is hypergeometric distribution, in which what we are doing, so we have a total number of pens in which 6 are damaged, we have to select 3, 4 are not damaged. Okay, now 3 in 3 we have to select exactly 1 damaged and 2 non-damaged. So what's the case here? So case here is from 6 select 1 into from 4 select 2, from 10 select 3. 3 by 10 is the answer. So what's this method is called? This method is called hypergeometry. So what's the hypergeometry? The hypergeometry is method is used when we can't find the independent. Here the events are dependent, as I mentioned here. I don't really yeah. So here it's used when dependency is there, dependent event. Okay, got it. Now let's say if we know that here the events are dependent. Why? Because we are without replacement. Now if the case is like with a replacement, means we can put it back with, if with replacement is the case, then you can know, you can see that here we can easily use a binomial distribution. So we have n is equal to 3, x is 1, p is 6 by 10, q is 4 by 10. So how you gonna solve? You're gonna solve this question. 3c1 6c10 power 1, 4 power 10 power 2. If you solve, you will get answer as 0.288. Now also here we took success as a p, and what's the p? It's damage. Now you can do the reverse thing also, that I'll give you to the homework, and I want to see whether you can solve it. So what I'm trying to say is, here we select one damaged as success, now select two non-damaged as success. So here p will become 4 by 10 and q will become 6 by 10. Here you will get 3c2, and the other thing you have to solve means 3c2 6 4c10 raised to 2 and 6c10 raised to 1. We will get the same answer. Let me, if you will not get anyone, if anyone is trying to face difficulty, x is 2 because 2 non damaged ball pen. So our p will become 4 divided by 10 and our q will become 6 divided by 10. Got it? Got it? The same thing, the same answer you will get here. Now that's all about the binomial distribution, the case which is dependent, when the events are dependent and all the other things are same. Then how we can solve the question? So with the help of hypergeometric distribution we can solve the question. Now let's start our today's topic, which is Poisson distribution. So why we are using the Poisson distribution? Poisson distribution is used to count the occurrence of event. Occurrence of event means if any person is standing on the road and he count the number of cars which are going in front of him, like 1 2 3 at a particular time. If we want to say like in 1 hour I saw 240 cars passed from here, then for that kind of distributed data we are using a Poisson distribution. So we can say that the Poisson distribution is a special case of binomial distribution only, or you can say some of the extended case where binomial distribution will not give a correct answer or there is some difference in the answer. So what's that case? The case is when n tends to infinite, means n is the value of n is very big at that time we are using a Poisson distribution. Now I am going to derive the formula of the Poisson distribution, so you have to understand it very calmly. If you have any question, then just post down comment, I will try to give the answer of it. So I think the red pen is fine. Now we are going to derive the formula for Poisson distribution. So we are starting from binomial only, ncx p raised to x q raised to n minus x. Now we know that, what we know that p q raised to n we can write as q raised to n upon q raised to x, and p raised to x upon q raised to x. We can merge. So what it become? It become ncx p upon q raised to x into q raised to n. Okay, now we also know that what q equal to 1 minus p. So replace it. ncx p upon 1 minus p raised to x, and again if we are replacing q to n, why I am not, yeah, okay, because x I'm only the forgetting the things. Okay, now what's the next? Now the next step is, so we know that in binomial the value of expectation is n into p, so we can write as a mean or lambda, or we can write as mean equal to n into p. So if we want to write in terms of symbol m equal to n into p, so we can say that p equal to m upon n, and here if our n tends to infinite, then from the equation if n tends to infinite, then we can say that p tends to 0. Got it? Yeah, got it. If n tends to infinite, then p tends to 0. So let me put the value in above equation. So what we got? ncx then 1 minus, no, not 1 minus, what's p, m divided by n, then 1 minus m divided by n raised to x into 1 minus m divided by n raised to n. Now we are putting limit here, the limit n tends to infinite. Try to find the formula. So limit we can give to the individual, like limit to this, then this, then this. So let's solve by giving limit to individual term. So first we are giving limit n tends to infinite to n of x, and the other one main thing is also that here we can see that m raised to x upon n raised to x, so I am taking n raised to x here. Now if we are expanding ncx, so what we are getting? We are getting n factorial n minus x factorial into x factorial divided by n raised to x. Okay, now let me give you, now just rearrange it, n factorial n minus x factorial and n raised to x. Now let's see, if we have x equal to 5, then the same equation can be represented as n factorial, then n minus 5 factorial. Let's consider this two term only. So what we can do? We can do like n minus 1, n minus 2, n minus 3, n minus 4, n minus 5 factorial. Can we write like this or not? Yes, we can write n minus 5 factorial, and what's the remaining thing? Here 5 factorial n raised to 5. So can we remove this and this? Yeah, the same thing we can apply above in above equation or not. So yeah, so let me write like this, n minus 1, n minus 2, like that, like that, like that, like that, like that. Do sorry guys, factorial n minus x plus 1. You can put the value and you can check it. Like if we are putting a 5, we are getting n minus 4. Okay, and here we have n minus x factorial. Now what we have, we have n minus x factorial, then x factorial, then n raised to x. Just remove this 2. So we have this equation currently, n into n minus 1 into n minus 2 up to n minus x plus 1 divided by x factorial n raised to x. X factorial into n raised to x. Now another thing. What another thing? We know that here we have n5. Here we have also limit n tends to infinite. Okay. Now here what? If we have number of terms in the numerator 1 2 3 4 5 terms, give each 5 term 1 n, like n by n, n minus 1 by n, n minus 2 by n, n minus 3 by n, n minus 4 by n. Okay, so we have n power 5 and we are giving each n to the each term in the numerator. Oh, yeah. So what we are getting here 1, then n minus 1 by n, then n minus 2 by n, then n minus 3 by n, then n minus 4 by n. So 1 into, please listen me carefully, 1 into 1 minus 1 by n, 1 minus 2 by n, 1 minus 3 by n, like that 1 minus 4 by n. Okay, so the same thing I want to do here. What I want to do the same thing, but which thing? The thing is I want to give the n to the all the above terms. So what I get limit n tends to infinite, then give to the each n 1 minus 1 by n, 1 minus 2 by n, up to 1 minus x plus 1 by n upon x factorial. Now just put a value n tends to infinite. If we are putting a value n tends to infinite, then 1 upon infinite will become 0. So what we are getting at the end, answer is 1 upon x factorial. This is not the final answer, so we are replacing 1 upon 1 by n factorial here. Okay, now let me go back to here. So what we are getting, 1 upon x factorial into what, into, if we are giving here n as a infinite. Okay, so what we are getting, 1 minus m upon infinite, it will become 1 minus 0, so 1. And here if you remember that I took n raised to x from here and divide by here as you can see. So here we have m raised to x, so what we are getting, m raised to x. Now if we are giving this limit to this function, so after putting limit we are getting 1 raised to infinite, and we have a formula for solving the question of 1 raised to infinite direct. So here we are getting e raised to m, but minus. If you want to solve me the limit, then I can also solve it like here, limit n tends to infinite, 1 minus m by n raised to n. Yeah, let me check. Yeah, it's true. Now this is the form of 1 raised to infinite. So for 1 raised to infinite form, we can use e raised to g of x. So g of x is n, and 1 minus f of x, no, f of x minus 1, f of x minus 1. So we are solving the limit part, n this one minus m divided by n, so we are getting e raised to minus m. Now let me write the final equation that we are getting. What's the final equation? I think so, just replace here e raised to minus m. So what's the final equation of Poisson distribution? So the final equation of the Poisson distribution is m raised to x into e raised to minus m upon x factorial. Here m, or you can also write the e raised to minus lambda raised to x upon x factorial. So here this m is, let me write, क्योंकि यहीं तक आते हुए कई लोग भूल गए होंगे कि ये m और n है क्या. M and n both are mean, or we can say average, or you can say expectation. Got it? So this is how we are getting the formula of Poisson distribution. So I also give you the derivation of the formula from the binomial theorem. When we'll use this formula, we are using the formula when, so like in previous one binomial also we have some condition in which we are using the Poisson distribution or binomial theorem. Also here there are also some condition. So the previous ones are also the same, like independent, then p plus q equal to 1, then x is belongs to discrete random variable, and now the next thing is n tends to infinite and p tends to 0. So these are the condition which is useful if you want to find or check whether we can use here Poisson distribution or not. Like in previous one we also check for the expectation and variation. So here we are going to see also. So here the expectation and variation is same, which is equal to what you can say as lambda, you can say as m, or you can say as mu. If you want to check, you can check, and here we can say the value of lambda is m into p. Okay, so this is all about Poisson distribution. So if you want to solve a question, then no, today we are, this is the easy concept. You can find the question from the internet, yeah, or you can search for any previous one, get question. So what you have to see in the question, if these things are given, if you want to check whether we can use the Poisson distribution, if question itself will tell you that use the Poisson distribution, then you can use the Poisson distribution. If the difference of n and p is very high, means p is equal to, in any question the value of p is 0.01 and n is 1000, so you can say that infinite is not a specific value. The infinite value comes with respectiveness, means the, if we are talking about the infinite, so for minus 1 lakh, the 1 million is a infinite for with respect to minus 1 lakh. So that's we can say about the infinite. Okay, so that's how we have to check here with the value of n and with the value of p. Or else, or the other thing in given in question, if it's not mentioned about the Poisson distribution, the occurrence of the event, like if it's saying then the, for a particular time, if I'm standing on a road as an observer and I can see the bike is moving from the road, so for the 1 hour the average number of bike are moving are 10, 20, or it gives in terms of average, because we know that the formula, if we want to find the probability, so here x is directly dependent to m. So in question, if it is talking about the average, the mean, the value of n and p have a big difference, or the occurring of the number of event, then we can use a Poisson distribution. Okay, that's all guys. So today we saw about the Poisson distribution, all the case about the Poisson distribution. If all the property of the binomial distribution is same except one, which the dependency, if it is dependent, Then we, for solving the question, we can use the general method also, or we have another method. Which method is that? The method which is known as hypergeometric distribution. If anyone wants me to explain this again, then I can explain it. So first we are using ncx p raised to x q raised to n minus x. This is the formula. Now we are replacing q with 1 minus p. So this is what we are getting. Now we know that expectation is n equal to p. From e of x we are replacing with m equal to np. Now putting the value of p, where p, putting the value of p or replacing with m by n. So this is how we are getting, and we know that when n tends to infinite, p tends to 0. So put the limit here, and after finding the first limit, the limit of the second, and the limit of this third, we are getting the solution which we want. If you find this as difficult, so just check it now. N factorial n minus x factorial, okay, here n minus x factorial, okay, but I think you know n factorial n minus x factorial upon ncf n raised to x. Now just remember this example. We can remove like this, so n minus x plus 1, then give this n raised to x to each n, and after this we are getting 1 upon x factorial. Now after solving the others limit also, this is limiting, solving the using limit, we are getting the answer. What's the answer? You can like e raised to minus m raised to x upon x factorial. X is the occurrence that we have to find. Okay, e raised to minus lambda raised to x upon x factorial. So thank you guys for listening me. This is all about today's lecture. Thank you. If you like, if you want the material, the link I'll provide in the description, you can find from that. Okay guys, thank you.